All right, for this lesson we are going to practice working with our differentiation rules. So the chain rule is something you need to make sure that you know before you do this lesson because it's embedded in the finding the derivative of our various functions that we have here. Our first example is y equals 1 over 2x plus, and then in brackets 3x minus 1 all squared. Now, we could use the quotient rule with this, along with using our chain rule. However, I find it a bit easier sometimes to work with that by rewriting the denominator with a negative exponent. So I'm going to take what I have on the denominator and just put that all to the negative 1 for that particular one. I also then can now apply that chain rule. I could expand and simplify that 3x minus 1 all squared, expand that, simplify it with the 2x, and then work on my chain rule, but I'm just actually going to go ahead and start the derivative here. So if I apply that chain rule, that negative 1 in the front is going to, or up in the exponent, is going to come down front. I'm going to leave what's in the bracket as it is for the moment. So, and then that the exponent gets reduced by 1, so that new exponent will be a negative 2. And then I have to multiply by the derivative of what's inside. So if I take the derivative of 2x, I'm going to get a 2. But then when I look at this, the 3x minus 1 all squared, I can apply the chain rule to that, the derivative of what's inside. So the 2 exponent here comes down front. We're going to have 3x minus 1. And now that's going to be, oops, there we go, 3x minus 1. And instead of an exponent 2, we're going to reduce that by 1. That just makes an exponent of 1. But then I have to times that by the derivative of what's inside that bracket, which is a 3. Okay, so now we're going to expand and simplify here a little bit. Not tons, but a little bit. So on the top, we are going to have that negative 1. This is going to slide down to the bottom because it has an exponent of negative 2 on it now. And then I'm going to simplify this bracket here, which will take us maybe a little bit of work. We've got 2 plus, and then the 2 times the 3 would be a 6. And then that 6 is going to multiply what's in the bracket here. So 2 plus, and if you need to take steps on this, you can. So I'll put the step in. But if you can do it all in one without making a mistake, that's the key. Then you could do that. All right, and I'm just copying down that part here, and now it's moved to the bottom, so its exponent becomes a positive. Working through this, we've got negative. We're going to have 2 plus 3 times 6 is 18x. 6 times negative 1 would be minus 6. All over that denominator. 2x plus 3x minus 1 squared, all squared. And combining like terms on the top, we're going to have negative, and then 18x minus 4. Ooh, that has a common factor I could take out of that. 2x plus. So the denominator I'm not doing anything with. Quite often we don't need to do much with the denominator because we're working mostly with the numerator in terms of finding our critical numbers. Bob might actually take that common factor of 2 out and make that a negative 2, 9x minus 2. So critical number for this would be x equals 2 over 9. And there we have our derivative for that function, combining a number of rules. Okay, moving on to another example here. Okay, so this example gets quite complicated. If I didn't have the second bracket here, if I didn't have the part I underlined in green, and I only had that first part, I could do that using the chain rule like we had learned in the chain rule lesson. However, we actually have the product of two things that we have to use the chain rule with. So this is going to get fun. We're going to find the derivative, so y prime. We know that the product rule says the derivative of the first. So let's take the derivative of the first thing I've got underlined in green. That exponent comes down front, times or multiply what we have in that bracket, reduce the power by 1, times the derivative of what's inside, which would be 6x squared minus 1. So that's the derivative of the first, and then that has to multiply by the second. So 7x plus 3 all to the 5, plus the derivative of the second. So 5 comes down front. We're going to have our 7x plus 3, and that's now going to be to the exponent of 4. We reduce that exponent by 1, times the derivative of what's inside. So that's the derivative of the second, and we have to multiply that by the first. So 2x cubed minus x all to the 4. Now, like, that would be gross if we tried to expand and simplify that all out. So we're going to use our factoring skills here. You should see that we have really two terms separated by this plus sign that I've underlined in red. Now, in those two terms, I am seeing a factor of 2x cubed minus x here and a 2x cubed minus x here. When we so that's common. When we common factor, we look for the smallest power of that, the smallest exponent on that. That is our common factor. So I'm going to start to common factor this. I know that 2x cubed minus x to the 3 is a common factor. I'm also noticing that both of these have a 7x plus 3 in them, and the lowest power of that is to the 4. So 7x plus 3 to the 4 is a common factor. Okay, using our common factoring rules. So that's what we have here. Now, I'm going to see what I have left when I divide those two terms by these things. So I'm going to have a 4 left. I don't need any powers of the 2x cubed minus x because I've taken them all out. I need this, and I need one factor of the 7x plus 3. So in here I need a 4. We need the 6x squared minus 1. And we need one power of 7x plus 3 to boost that up to a 5. Okay, then looking at the next term here, we need a 5 and a 7. So 5 times 7, I can just put those together and make that a 35, or you could write them out separately if you like. The 7x plus 3 to the 4 is already pulled out as the common factor, so I don't need any of that, but I do need one factor of 2x cubed minus x to take that up to a power of 4. So we're taking that 35 and going to multiply that by 2x cubed minus x. All right, so we have a factor, a factor. We're going to simplify what's inside that bracket next. So we keep these factors as they are, 2x cubed minus x all cubed, 7x plus 3 all to the 4. And then in this bracket, I'm going to expand and simplify my two brackets first. 7 times 6 is 42, x cubed plus 18x squared, and I hope somebody's watching and following carefully and making sure I don't make any mistakes with all this kind of multiplying, expanding and simplifying. And I don't know if I can squeeze this in here, plus 70x cubed minus 35x. Continuing on with our expanding and simplifying, this front part is just going to stay as it is. And then inside here, we're going to have 4 times 42, which is 168 x cubed, plus 4 groups of 18 would be 72, I think, x squared, minus 28x, 7 times 4 is 28, plus, minus 12, and then minus 70x cubed, and minus 35. Plus 70x cubed and minus 35x. Okay, so lots of places to go wrong in terms of expanding and simplifying. So you want to work really carefully as possible. Sometimes you just have to slow down a little bit and really think about step by step what it is that you're trying to accomplish here. All right, now inside that bracket I've got 168, and I'm going to add 70 to that, so 238 I believe. And use your calculator if you need to there. An x squared. I don't have any other x squareds to put with the 72x. And then we're going to have a minus 28 and 35. If I put 30, 65, 63, x, and then minus 12. Okay, inside this bracket now we have a cubic, and if we wanted to factor that further, we would potentially try factor by grouping, or go into our factor theorem that we learned in advanced functions. Okay, and I checked the quartic here, or cubic here, to see if there is anything that would go into that in terms of a nice number, and we don't have anything that works out nicely there. So that's as far as we can go with that particular question and coming up with its derivative. Let's try another. But I think I'll do another couple on another video just so I don't go over my time limit here.